Now that we've talked a little bit about this DMAIC process, let's focus on what do we mean by a problem. And when we think of problems, one of the things that happens is usually what we see first is a set of symptoms. Now, the symptom might be there's some complaints from customers, or maybe a product has been returned, or maybe something just didn't work right or feel right in the process. And so what we have out of that information is we detected something. Where did we detect it? When? Who detected it? And why is that considered such a critical thing? So what we want to do is at the very beginning is identify the scope of this thing that was gone wrong. What were the organizations that were involved? Is there a particular geographic area of interest or one place in a building or a process at step where that things are happening? Are there some constraints on this system? Who is the team involved? What are the resources? And if we can understand this scope, then we can maybe be able to expand this a little bit later as we need to seek to discover what was the root cause or the causal structure that created the system that we see in the first place. We also need to consider the practicalities. Do we really have good data? Does it really say what we think it's saying? Does this determine, how much understanding we really have? If we have bad data, then we don't really have much understanding at all. As Stephen Hawking said, the cost of bad data is the illusion of knowledge. So if we have bad data, we think we know something, but we don't really because the data was wrong. So how often do we operate this process? Do we operate the process on a regular basis so we see it often? Or is it so intermittent, maybe once a quarter or once a year, so we don't even have in our short-term memory how we did it? And maybe every time we do that process, we do it something differently. So have we isolated the different functions who are engaged in the process? Do we understand what their contributions are? So if we want to define a problem, there are a lot of things we really have to understand about the state in which that problem is existing. One way to do this is to separate all of what we call the rational subgroups of the problem. We can do this with a logic tree diagram. So we start in the head of the diagram with a definition of the issue. And then we break down what are the mutually exclusive components that define that. And then we provide detail to understand how is that completely exhaustive. So the McKinsey consulting firm often calls this a MECE diagram. I prefer to think of it as what Aristotle taught in the categories in 300 BC, and that is break problems down into the smallest components by which you can analyze them. So as we take a look at this, what we start seeing is when we have this problem, we're faced with an issue. I don't know what the issue is. The issue could be anything. And so once we define this issue, we have to say, who's the customer? Who's the person receiving it? How does that customer think about the deliverable they're looking for? And we're going to call this deliverable a why. It's an outcome measure. And then we want to measure what are the results of that why? How consistently have we been performing that why measure? What's the difference between what the customer wants for the why, what their expectation is, and the actual observed delivery? And that gives us a performance gap. And once we understand that gap, we should say, okay, but how well have we ever done it? What was our best day? What was our worst day? How consistent are we in performing this over time? And at that point in time, we're able to understand in the time history of work what's been going on. We see changes in the performance over time. And we can ask the question, what changed? When did it change? What else changed in the process? Why did we make that change? How did that change affect our customers? How did it affect our productivity? How much did it cost? And now we're ready to start thinking about this problem. And the problem is that gap between the desired performance and the actual performance. And so that gap is what we mean by a problem. So we have to identify in a problem state what should be changed. What is the output? What kind of improvement do we want to have? If it's productivity, do I want to reduce it? Do I want to increase it or control it? If it's cycle time, what do I want to do? Reduce, increase, or control? And then where is that point that we'd like to control it? Is it at the deliverable to the customer? Or is that a particular point in the process where we have a specific requirement? Now, there are a couple of things we should avoid in developing problem statements. First, we shouldn't set targets. We shouldn't say we're going to do this much improvement, like 10% improvement of this. And the reason is we don't know how much improvement's available until we measure it. So right now, if we set that target, we're guessing. So we don't want to guess. We want to let the scientific analysis of the process performance tell us how much improvement is actually reasonable. Because the reasonable improvement may be 60%, not 10%. And if you take a look at this just at the beginning, I don't know if I really want to commit to that until I see, wait a minute, there's 80% improvement, and I know if I do these tasks, I can get 60%. So that commitment is one thing we want to take off the plate at the beginning. We don't want to set a particular target. The second is we should not assume a particular solution. Let's not say we're going to solve this by doing this, because we don't know if there's actually a causal relationship. We haven't proven it. Again, we're working on theory opinion. We're working on our guesses and expectations. We want to use a scientific basis, and when we get into that improved stage, actually test to see, does that proposed solution deliver the performance improvement that we're seeking? So problem statement should seek to close the gap between the current state and the desired state. What is this performance gap, and how are we going to get there? That's going to be part of the analytic process, to understand what are the things we should do, how should we engage that process to make it actually work. So the idea is a problem statement is going to be, we want to solve a performance problem that we're going to formulate in an equation, which we say y is a function of x. Y, the desired state of outcome, is a function of x, process and input variables that we can identify, either performed by the workers or by equipment in the process, or by the sequence of work in which it's done. So the problem statement is going to be then a high-level definition of the problem that includes quantification of what we want to do in terms of change, as well as the expected effect on the experience of our customers. The output variable, the Y measure, is, if you will, the response as measured by the customer. And what we want to do is define this performance operationally. So we're going to come back and we're going to talk a little bit more about operational definitions and how we actually specify the components of the problem statement. Thank you very much, and we're going to continue this in our next video.